Okay, greetings and salutations. Okay, I am speaking to the future. You're hearing from the past in your present. All right, so a little extra there for Chapter 15, Chemical Engineering Extras. We're going to look at safety signs in the real world. Now, you may notice, you probably have seen something like this before. It may have had colors like this, or maybe it had pictures. But the bottom line is, you have seen safety signs before. And the point about this chapter, dealing with chemical engineering, it's chemical safety. We've talked about OSHA. We've also talked about material safety data sheets. But now we're going to be looking at safety signs. And with that, ladies and gentlemen, let's go ahead and let us get started. So what is it exactly? It's called the NFPA Hazard Identification System. National Fire Protection Agency. That's what it is. And you may end up seeing something like this on the doorway or on the side of a building, or maybe near a gas station, maybe where there is the propane filling station. Okay, but the colors are significant. So when you're looking at red, it has to do with fire. When you're looking at yellow, you're looking at the chemical properties of it. How reactive is it? Is it stable? Is it unstable? Blue, we look at human health. Um, and then for white, you deal with special hazards. Okay, now typically those are going to be some kind of a symbol. Sometimes they'll have words in there. But let's take a look example in the previous slide. When you look at the previous slide, you'll notice 4, 4, 4. So there's 4 for the fire, 4 for the chemical reactivity stability, 4 for human health. And then you look here at the white diamond, you notice that it's got the W with the bar across it. What that tells, pretty much for firefighters, ladies and gentlemen, that you don't want to use water. If this place is on fire, you don't use water to fight it, to put out the flame. And the reason for that is it's kind of like putting out a grease fire in the kitchen. You try to use water, you're going to make the fire worse. So that particular symbol is pretty important. That's knowledge that the firefighters want to have. Okay, the numbers. What's up with the numbers? Well, it tells us the hazard level that's connected with that category. The larger the number, there's a greater potential hazard. The smaller the number means there's less hazard. Now, the thing is, when you look at a diamond, they don't have to be in those colors. Okay, if it's not in those colors, but you see a diamond shape, it's still the same order: fire, chemical, special hazard, human health. That's it. That's it in the same order. That's just the way that it is. And it makes it easy. Seniors, next year, many of you, you're going on to university or you're going on to a JC. Chances are, when you walk by some of the buildings, you may end up seeing some of that. So let's look at the red diamond. That's dealing with flammability. Okay, so to 0, it doesn't burn under typical fire conditions. Now, again, that's typical fire conditions. Could you get something to burn if you take it to extremes? Sure. But we're talking about regular, everyday conditions. Now, a flash point, when you look at one, it says flash point greater than 93.4 Celsius or 200 Fahrenheit. A flash point, it's the temperature that the fire starts to go. It will burst into fire. Okay. So you can see here the fire needs more, the flash point needs more than about 200 Fahrenheit or 93.4 Celsius. It needs quite a bit in order for the whatever the substance, object, liquid, powder, whatever it is, to catch on fire. When you go at level 2, now that flash point moves down a little bit because now you're between 93.4 and 37.8. 37.8 is much closer to human body temperature. Okay. Now that flash point is somewhere in there. Now it says substance must be moderately heated or exposed to relatively high ambient temperatures before the ignition can occur. This is true. Okay. When you look at level 3, this is where, okay, again, they move it down again, where you're looking at a flash point between 37.8 Celsius and 22.8 Celsius. Okay. So what does that mean for Fahrenheit? You're looking at between 100 to 73 Fahrenheit. So now this is getting a little bit lower. So in other words, they're saying the stuff can be readily ignited under almost all ambient temperature conditions. Well, what do they mean by ambient? Ambient is just whatever the temperature condition is out there at that moment. That's what they mean. It's not it's regular temperature conditions for that day. Boom. Okay. Now, when you look at level 4, you kind of notice that that flash point there is now 73, between 73 and 100 Fahrenheit. Okay. And this is where you deal with flammable gases, materials that ignite spontaneously when exposed to the air. Now, as opposed to level 3, where it can be readily ignited, 4, it's spontaneously igniting. In other words, the moment it comes in contact with air, it just goes boom. You don't have a flame near it, you don't have a spark near it, nobody has poured gasoline. It's just this substance will just go boom when ignited with the air. Now, gee, I can think of one chemical element that could do something like that. Sodium. Sodium is one that you give it a moment when it comes out of the jar of kerosene, it will ignite and it will do so spectacularly. Okay, nasty stuff. But anyways, but we're talking about flammability hazard here. Okay, so when we look at red, think fire. So it's the flammability hazard. When we look at the blue diamond, okay, that's when we look at health. So again, it's the same scale from 0 to 4. 0 meaning that there's no real big deal. Exposure under emergency conditions would offer no hazard beyond that of ordinary combustible materials. Okay, nothing out of the ordinary. Level 1, exposure under emergency conditions could cause significant irritation. Aha, okay, that's where things are not going great. Then when you look at 2, exposure under emergency conditions could cause temporary incapacitation or possible residual injury. Whoa, hey, what are you talking about? Temporary incapacitation. Incapacitate means that you are not able to respond, you're not able to react to anything. You could be knocked unconscious. You could be injured that you couldn't move your legs for whatever reason, or you are not able to drag yourself out to safety, depending what it is. Okay. So when you look at level 3, exposure under emergency conditions could cause serious temporary or residual injury, even though prompt medical attention was given. Right. So again, you can have a temporary or residual injury. Okay. It's serious, even though you have the medical attention given on the spot, which typically medical attention given on the spot doesn't cure everything. A lot of times it's to prevent things from becoming worse. So if somebody is bleeding, for example, because of what has happened, the idea, what do you want to do? Well, you want to go and stop the bleeding, right? That would be kind of an important thing to do. Okay. Because you don't want the person to bleed to death. That would be, something that you'd want prompt medical attention for. And that's where first aid comes in. And it's always good for people to learn some basic first aid, basic CPR, those things. Level 4, very short exposure could cause death or serious residual injury, even though prompt medical attention was given. Okay. Yeah, try to avoid fours and threes. That would be the general rule for this, guys, is stay away from the fours and threes. But, that might be part of your work. You never know. But the information is there, and that's the important thing. Knowledge is power. Okay, and knowing this stuff helps. How about yellow? Well, yellow, we're looking at the chemical aspects of things here. So when we look at yellow, we're going to go and say for 1, 0, it's normally stable, okay? Even under fire exposure conditions, it's not reactive with water. Okay, cool. 1, normally stable but can become unstable at elevated temperatures and pressures, or may react with water with some release of energy but not violently. So again, this describes different chemical compounds. Normally stable, it can become unstable at elevated temperatures and pressures. So if the pressure and the temperature are higher than normal, okay, it's possible for the compound or the chemical or whatever it is to react. Okay. Now they also put in how does it react with water? Again, this would be useful information for the fire department, for firefighting personnel, to go in and have an idea. Do we go and fight this with regular water, or do we go and use a special foam, or do we use carbon dioxide? That's another way of putting out a fire. By giving carbon dioxide, you are starving the fire of the O2 that it needs. Okay? So 2, level 2, normally unstable and readily undergo violent chemical change at elevated temperatures and pressures, but do not detonate. Phew, okay, it's not detonating. Now detonate means to blow up. Kaboom. Also, may react violently with water or may form potentially explosive mixtures with water. Oh, goodness gracious. Level 3, capable of detonation or explosive reaction, but requires strong initiating source, or must be heated under confinement before initiation, or reacts explosively with water. Oh boy. Yeah, exactly. Okay. So, number 4, readily capable of detonation or of explosive decomposition or reaction at normal temperatures and pressures. Wow, this is more like an SCF SCP problem to me. Yeah, if you got that reference, enjoy it. If not, don't worry about it. But definitely, when you're at level 4 for the instability or reactivity hazard ratings, okay, you have to approach that with extreme caution. Okay, and it's possible, some people can lose their lives or get seriously injured because of the unstable nature of whatever the compound is. That's hard to say. But again, when you're knowing this ahead of time, you can make preparations and you cut down on the chances of people getting injured. Okay. Okay, let's see. White. Okay. So we got some things there. That's the special hazard ratings. So something like OX, W acid alk core, skull and crossbones, radioactivity. Okay, let's just go through them. An OX or OX, that tells us there's an oxidizer in there, a chemical that greatly increases the rate of combustion slash fire. Yeah, oxidizers can be very nasty things to deal with. Okay. W, unusual reactivity with water. This indicates a potential hazard of using water to fight a fire involving this material. Okay. Yeah, that would probably be an important thing. Acid. Okay, that's a tough one. It's an acid. It's a corrosive material that has a pH of less than 7.0. Remember that pH scale. Let's say pH from 1 to 14, or should I say 1 to 14. It doesn't matter. But the thing is, pH of 7 is neutral, okay? Equal amounts of acid and base in there, all right? But it's still neutral. It's mostly water. But when you go down pH of 6 to a pH of 1, the concentration of acid gets greater and greater. That's not saying it's a strong acid. Strong and weak acid, strong, weak base, that's a completely separate thing that has absolutely nothing to do with the concentration of it. Okay? When you talk about strong or weak acid, you're talking about how well does it dissolve in water. Strong acids dissolve great in water, like 95%. If you're looking at a weak acid, like vinegar, for example, maybe 5% if you're lucky. Okay. So, but that doesn't do anything for the pH here. It doesn't. Okay. Now, ALK stands, also tells us it's an alkaline material, also known as a base. These caustic materials have a pH of greater than 7.0. Now, when you see that word right here, caustic, okay? Caustic means that it's going to cause you harm. It's going to do something to your skin. So bases, again, you could look at drain opener. That's a wonderful base. It just basically goes through base, basically. Oh my goodness, I can't believe I'm cracking jokes here. Okay. So yeah, a base will go through like a drain opener. That's a fairly concentrated base. You put that in the drain. The whole point about it is it basically dissolves the organic material that are there and unclog your drain. So that's why you have to be careful. Now, when you look at core, COR, it tells us that this is a material that is corrosive. It could be either an acid or a base. It might be something else. It depends. Okay. Now, skull and crossbones. You know it. You've seen enough pirate movies, Pirates of the Caribbean. Okay, awesome soundtracks. First one was still the best. Disney killed Star Wars. Okay. So, skull and crossbones denotes a poison or a highly toxic substance. Is there a difference between the word poison and toxin? Yes, there is a difference, but most people in everyday life they think it's the same thing. Okay? Like velocity and speed. They think it's the same thing. You'll have to have me in physics for that one. Okay? But a toxin is what will kill you. A poison can make you very sick, but in theory you should be able to survive it. But a toxin would kill you. All right? Now, the next one is the international symbol for radioactivity. Now, that tells us of things like radioactive hazards, radioactive materials that are extremely hazardous when inhaled. Yeah, that would be kind of an important thing. Breathing in radioactive particles into you, depending on how radioactive they are, that can kill you or it can cause you cancer. I mean, there's a lot of different things that can happen on that. So we want to be careful about that. Radioactive, radioactive. Time for the real world, baby. The real world, baby. Radioactive, radioactive. Okay, so here we have an example of a diamond. All right. So when we look at it, it says, so let's start with the red. So we have a 4. And you got a quick thing here. So what's the flash point? Well, it's going to be below 73 Fahrenheit. Okay. Ooh, yeah. In other words, the stuff's highly flammable. Probably would want to be careful about that. Now, we go from the flammable to the chemical stability, the reactivity. Now, that's a 2. Now, it's a violent chemical change. Okay. Violent chemical change, possibly. Yeah. Now we go to the special hazards. Notice that W with the bar through it. Guess what it says? Use no water. Oh, right. Exactly. Then we look at the last one, dealing with health hazards. That's a level 3. That's extreme danger. So if you are not careful, you can suffer harm. you could possibly die from it. Okay, so do the right thing. Now, here's one example. This was posted at a public swimming pool chemical storage area. Now, if you notice, you got some extra hazards in there that are listed on the notice diamond. So it's not a perfect diamond, it's more like a diamond that is about to reproduce by binary fission, cytokinesis. Come on, bio guys. You can see it. Here's that process. All right. Now let's take a look. So, 4 in the red, that's fairly flammable, pretty dangerous. 2, you've got some possible chemical violet changes there. Look at the 3 blue. Ooh, yeah, that's not good for our health. Not the worst, but not good for the health. We have to be careful. Oh my Lady Gaga, look what we got here. We have got 1, 2, 3, 4 hazards in there. Let's see what we got. We got the don't use the water, okay, to fight it. We have an oxidizer in there, so that can do wonders for a chemical reaction, especially for you AP chemsters. Okay. Corrosive. Okay. Corrosive. Cry. I may not have listed it in there. No, I did not. Okay. I'll have to look that one up. I'll have to see. But again, if they're listing it as a hazard, then that tells us something. We need to be careful about that. Other pieces of information. Well, again, a chemical will be considered hazardous and all appropriate safeguards must be used if the NFPA diamond has any lettering in the white section, the lower or southern section, or contains a number 1 or greater in any of the 3 remaining colored sections. If the NFPA rating is a 3 or 4, that's when you use extra care. Look, even if it's a 2, I would still be careful about that. So here's another example here. So this is propane. Okay. What is the most dangerous part of the propane? Well, that's kind of a no-brainer. You notice that you're going from 0 to 4. 4 is the greatest risk. Where's the greatest risk with the propane? It's not the reactivity. That's like, we don't have to worry about that. The 1, yeah, there can be some possible issues, but I mean, the thing's got to blow up. And of course, you're not going to inhale propane. The red. That means it's really easily flammable. And if you notice they put danger, propane, at least they're telling you what's in there, and no smoking. Yeah, that would be kind of an important thing. No smoking. Whew. So some more examples here of things like ethanol, okay? Caustic soda, nitroglycerin. But for a lot of people, they should be looking at bleach. Now, bleach is an oxidizer, okay? Can do wonders in a chemical reaction and the rate of the chemical reaction. And then look at the potential health issues. Oof. Oof, 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 oof. Okay? So, with that, ladies and gentlemen, for a bit of fun, what hazards are these little characters? Okay. And really, when you think about what was the objective for this, why were we doing all this? I wanted you guys to know what the safety diamond was about. What did the colors mean? What did the numbers mean? What did the symbols mean? In the special hazards section, because who knows, that could be useful information for you in the future. There are other variations out there of safety diamonds. They may be colorless, but they may put numbers or they may put symbols in there. But the idea is still the same. It's to let people become aware of what they can be dealing with. All right, guys. So That's it for the safety diamond. There's going to be an assignment on this. All right. And we are done. We're done, ladies and gentlemen. We are done. Okay, now I'm trying to figure out. Okay, here we go. Save as a video. Okay.